Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is shortcut methods to find PI. This is the second method to find the PI, means to find the particular integral. And this topic is from first unit, linear differential equation with constant coefficients. Already we have discussed the first method, general method to find PI. Now this second method, shortcut method to find the PI. Now there are different cases or type, depends on the function f of x. Now the first type or first case, when f of x is equal to e raised to x, means exponential function, where a is constant. Now the formula for pi is 1 upon phi of d into f of x. Now if the function is here particular exponential function e to the power x. Now how to find the pi for this exponential function? It is equal to, so the formula for pi is 1 upon phi of d into e to the power x. Now replace this d of phi of d by the coefficient a. That a is from the exponential function, the coefficient of exponential function. So replace the d by a, and so the pi will be 1 upon phi of a into e raised to x. But the condition is here that phi of a must be non-zero. The denominator term phi of a must be non-zero, because if it is zero, if phi of a is equal to 0, then it is the case of failure. If denominator is 0, then you get infinity. So the condition is there that phi of a must be non-zero. If phi of a is equal to 0, then it is the case of failure. And then in that case, how to find the pi? Then the formula is pi is equal to, you multiply in numerator by x and then take the derivative of denominator. Your denominator is phi of d, you take the derivative of denominator, means derivative will be phi dash of d, and after taking the derivative of denominator, you replace that d by a, and so the term will be phi dash of d, and then replace that d by a, means your term will be phi dash of a, and the function as it is e raised to x. So your pi is x upon phi dash of a into e to the power x. Again the condition is there, phi dash of a must be non-zero. If it is equal to 0, then again case of failure. If it is again the case of failure, then again you repeat the same procedure, means multiply in numerator by x, take the derivative of denominator. After finding the derivative, you replace the d by a, and again the same condition will be there, the denominator must be non-zero. So you repeat the same procedure. Now in that first type or case, first case, there are sub cases. That sub case 1 is that if your phi of d is in the form of d minus a in to the power r, this is the particular form of phi of d, and the function is same e to the power x, then in that case the pi is x raised to r upon r factorial into e to the power ax. This is case sub case 1. Now sub case 2 is if the phi of d is phi of d into d minus a to the power r, and the function is same exponential function here. Then how to find the pi? The formula is here. You first replace d by a of phi of d, and then the formula for 1 upon d minus a to the power r into e to the power x is same as sub case 1. Solve this term 1 upon d minus a to the power r into e to the power x by the sub case 1 result. So your result will be, your pi will be 1 upon phi of a into x raised to r upon r factorial into e to the power x, and the condition is that phi of a must be non-zero. After replacing d by a here for phi of d, your denominator phi of a must be non-zero. That is the condition. If it is 0, then it is the case of failure, and you know how to find the pi. discuss it. Case 1. Subcase 3. If f of x is equal to k, constant, then how to find the pi? Then the pi is equal to 1 upon phi of d into k, because your function is a constant term k. Then how to find the pi? Then in that case, you replace that d by 0. D by 0, and that function will be phi of 0. Why we are replacing d by 0? Because when there is a constant function, then in that case we assume here e to the power 0x. The value of e to the power 0x is 1, so we can assume here e to the power 0x. And it is an exponential function, and the coefficient of exponential function is 0. So you replace d by 0, and then your pi will be k upon phi of 0, and the condition is that phi of 0 must be non-zero. If it is 0, then you know how to find the pi. If phi of 0 is equal to 0, then it is the case of failure. And discuss in case 1. Now subcase 4. If f of x is equal to a raised to x, then how to find the pi? Pi is equal to 1 upon phi of d into a raised to x. Now when the function is a raised to x here, then we can rearrange this function a raised to x as e raised to x into log a. Taking log and taking exponential function, we can rewrite this function a raised to x as e raised to x into log of a raised to x. And then it will be a case of exponential function after replacing or rearranging a raised to x in the form of e raised to x into log a. Then it is the case of exponential function. So replace d by the coefficient, and here the coefficient of exponential function is log of a. This is the constant term. So you replace that d by log of a, and so your pi is 1 upon phi of log of a into a raised to x. Here we can write a raised to x as e raised to x into log of a, because if we can write this x as a power of this a, so the term will be e to the power log of a raised to x, and then e and log function, they cut to each other, cancel each other, and so you will get your original function a raised to x. So that we can write a raised to x as a e raised to x into log of a. So this is the case 1 or type 1 results. Now the examples on type 1 or case 1 example. First example, solve d square minus 2d minus 3 into y is equal to 5 plus e raised to 2x plus 3 raised to x. Now this is the reduced form of LD. Phi of d into y is equal to f of x. Here d square minus 2d minus 3 is equal to 0 is an auxiliary equation. It is the quadratic equation, so it has two factors. We can write this quadratic equation in this form: d minus 3 into d plus 1 is equal to 0. Minus 3 plus 1 addition is minus 2, and the multiplication of minus 3 and 1 is minus 3. So the factors are d is equal to 3 and minus 1. So the complementary function is here c1 e raised to 3x plus c2 e raised to minus x. These factors are real numbers and different. So its complementary function is very simple. There are two different distinct terms for the complementary function. Now the pi, particular integral, the remaining half solution. Pi is equal to 1 upon phi of d. Phi of d is d square minus 2d minus 3 into the function is here 5 plus e raised to 2x plus 3 raised to x. Now how to find pi? There are three terms. So you separate all the three terms. This 1 upon d square minus 2d minus 3 into 5 plus 1 upon d square minus 2d minus 3 into e raised to 2x plus 1 upon d square minus 2d minus 3 into e raised to into 3 raised to x. Now, how to solve for first term? 5 is a constant term. So when there is a constant term, then we replace d by 0. So replace d by 0. The first term 0, middle terms also 0. So only non-zero term is -3. And this 5 as it is. So it is -5/3 plus. Now the second term is exponential function e to the power 2x. How to solve for exponential function e to the power 2x? Replace d by the coefficient. The coefficient is here 2. So replace d by 2. 2 square is 4. So right here 4 minus 2 2s are 4. Again the value of d is 2. 2 2s are 4 minus 3. Now the next term, the function is 3 raised to x. It is the function in the form of a raised to x. When the function is a raised to x, then we replace d by log of a. Now the value of a is here 3. So replace d by log of 3. So the next term. So from this step, next step, this first step -5/3 as it is. Now simplification of second term, 4 minus 4 0 minus 3 non-zero term. So 1 upon -3. So -1/3. This function e to the power 2x as it is plus replace every term of d by log of 3. Log of 3 whole square minus 2 into log of 3 minus 3, 3 raised to x. So this is the pi for the given LD. And then in last, the general solution is y is equal to cf plus pi. So y is equal to c1 e raised to 3x plus c2 e raised to -x minus 5/3 minus 1/3 e raised to 2x plus 1 upon 1 upon log of 3 whole square minus 2 into log of 3 minus 3. This is the solution, general solution for the given LDE. Now the next example, solve solve d cube minus 5d square plus 8d minus 4 into y is equal to e raised to 2x plus 2 into e raised to x. So here phi of d is d cube minus 5d square plus 8d minus 4. Equate it equal to 0. So it is an auxiliary equation. It is a cubic polynomial. So you find out the factors using the synthetic division. And then you will get, after finding one factor, you will get a quadratic equation. You find out that factors of quadratic equation. So total 3 factors. Here the factors are 1, 2, 2. And so the complementary function is the 2 roots are equal and the remaining one is distinct. They all are real numbers. So complementary function is here c1 e raised to x plus c2 plus c3x into e raised to 2x. The second and third term is for the factor 2 because 2 is repeating 2 times. So we have already written the formula for complementary function. When 2 roots are equal, then how to write the complementary function? So here we are using that same formula. When 2 roots are equal, then the rule for complementary function. So this is the complementary function for this given example. Its pi is equal to 1 upon d cube minus 5d square plus 8d minus 4. And the function is here e raised to 2x plus 2 into e raised to x. Now separate both the terms. So we have the formula, the factors of d cube minus 5d square plus 8d minus 5 are here. D minus 1 to d minus 2 whole square to e raised to 2x plus 1 upon d minus 1 to d minus 2 whole square into 2 into e raised to x. Separate these two terms. Separated here both the terms. Now solve for everyone. For first term, the function is exponential function. Exponential function, the coefficient is 2. So replace d by 2. If we replace this d by 2, 2 minus 2 will be 0. So it is the subcase 1 upon d minus a to the power r into e raised to 2x. The factor and the coefficient both are same here. And first term, if we replace d by 2, then 2 minus 1 is 1. So we can easily replace here d by 2. But for this, you use that formula 1 upon d minus a to the power r into e raised to x. So first solve for d minus 1. So replace d by 1, replace d by 2. 2 minus 1, 1. So we have this term plus second term 2 constant, right? 2 as it is. Now exponential function is e raised to x. The coefficient of exponential function is 1. So replace d by 1. 1 minus 1, 0. So it is the case of failure. So you solve for d minus 2 first. If we solve for d minus 2 first, the coefficient of exponential function is 1. So 1 minus 2 is minus 1. Minus 1 square is 1. So this is the next term, 2 upon d minus 1 into e raised to x. Now again solve for d minus 2 whole square. Here the function is e raised to 2x. So if we replace 2 d by 2, then it is a case of failure. So it is that type 1 upon d minus a to the power r e raised to x. So the formula is here. The value of r is here 2. So x square upon 2 factorial into e to the power 2x. And here, if we replace this d by 1, because coefficient of exponential function is 1, then it is a case of failure. Then multiply in numerator by x, derivative of denominator, derivative of d is 1, and for this one it is 0. So derivative of denominator is 1. Or you may use the same formula 1 upon d minus a to the power r into e raised to x. The factor is 1, the coefficient is 1. So, and the value of r is here 1. So, x raised to 1 upon 1 factorial into e raised to x. So for both the terms, we are using the same formula, and that formula is here. We are using this formula. 1 upon d minus a to the power r into e raised to x is equal to x raised to r upon r factorial into e to the power x. Okay, so this is the pi, and the general solution is y is equal to cf plus pi. So you just add complementary function and particular integral, then you have the general solution here. So here are some examples for homework. D square plus 4d plus 4 into y is equal to e raised to minus 2x plus 2 raised to x plus 3. So this is the second example, and answers are given. You try to solve these two examples. You take it as a homework. Now the second type or case 2 is here of shortcut method. The case 2 is when function is f of x is sine of ax plus b or cos of x plus b, where a and b are the constants. Then what is the formula for pi? Pi is equal to here 1 upon phi of d square into sine of ax plus b. So when there is a sine of ax plus b function, then in that case, we always replace d square by minus a square. We replace only the terms of d square and not of d. Remember that we always replace the term of d square by minus a square when there is a sine function sine of x plus b. So replace the terms of d square by minus a square, and so the next term will be 1 upon phi of minus a square into sine of x plus b. And the condition is that phi of minus a square must be non-zero. The denominator must be non-zero. If it is equal to 0, then it is the case of failure, and then its pi is equal to multiply. It is the case of failure. So you know how to solve the term case of failure, we always multiply in numerator by x. Then we take the derivative of denominator, derivative of this term, derivative of 5 function will be 5 dash. And after finding the derivative, you replace the terms of d square again. Replace the terms of d square by minus a square into sine of x plus b. Again, the condition is here that phi dash of minus a square must be non-zero. If it is 0, phi dash of minus a square is equal to 0, then again the case of failure, and then you repeat the same procedure. And same result formulas are there for cos function also, cos of ax plus b. In cos function also, you have to replace the terms of d square by minus a square. And in the same way, you find the pi for cos function. Now here, you revise the formulae or trigonometric results. That first one is sine square theta is equal to 1 minus cos 2 theta by 2. Cos square theta is equal to 1 plus cos 2 theta by 2. Then product formulae, 2 sine a cos b is equal to sine of a plus b plus sine of a minus b. 2 cos a cos b is cos of a minus b plus cos of a plus b. 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. Now the examples here. Solve d square plus 4 into y is equal to sin x plus cos 2x. Here it is the reduced form of LD, and here auxiliary equation is d square plus 4 is equal to 0. If it is the quadratic equation, d square plus 4 is equal to 0. So it has two factors, and factors are d is equal to plus minus 2i. Because if we shift this 4 in RHS, the term is d square is equal to minus 4. Since the square is a negative number, so here we introduce I square. So d square is equal to 4i square. And so the factors are d is equal to plus minus 2i. So the complementary function here, so the roots are complex roots, plus 2i minus 2i. Here the real part of complex number is 0 and imaginary part is 2. So the complementary function is c1 cos 2x plus c2 sin 2x. Now the pi, the formula is 1 upon d square plus 4 into sin x plus cos 2x, because the function is here sin x plus cos 2x. Now there are two terms, you separate both the terms, and so that you will get the term 1 upon d square plus 4 into sin x plus 1 upon d square plus 4 into cos 2x. Now for sine function, we replace d square by minus a square. The coefficient of x is here 1. So the value of a is 1. So you take the square of 1. Square of 1 is also 1. So replace d square by minus 1. And so the term is here 1 upon minus 1 plus 4 into sin x plus. Now the second term, the function is cos 2x. Same rule is there for cos function also. The coefficient of x is here 2. So the value of a is 2. The square of a is 4. Replace your d square by minus 4. If we replace d square by minus 4 plus 4, 0. Case fails. So multiply in numerator by x and then take the derivative of denominator. Derivative of d square is 2d. And this cos 2x as it is. Now simplify the terms. Minus 1 plus 4 is 3. So sin x upon 3 plus x upon 2. Now sin 2x upon, there is one correction here. This is d. This is d. And this is d here. The term is here d. Okay. Okay. So the term is here x by 2 into uh, sorry, actually it is the calculator term. So the calculator term is here sine 2x by 2. Calculator term is here. This is correct. See, x by 2, this x by 2 as it is, and cos 2x by d. Now 1 by d is integration. When d is in denominator, in that case we take integration of the function. So 1 by d of cos 2x means integration of cos 2x. Integration of cos 2x sine 2x upon 2, because the coefficient of angle is 2. So integration of cos 2x is sine 2x by 2, and this x by 2 as it is. So it is correct. So the answer is sin x upon 3 plus x into sine 2x by 4. 2 2s are 4. So this is your PI. Here you note that 1 upon d of cos 2x means integration of cos function. Because our original function is cos function, cos 2x from the given LDE. So you just integrate cos 2x and not x into cos 2x. This x is because of the case of value. So this x by 2 as it is. So this is the PI here. And then the general solution is y is equal to CF plus PI. Okay, the next example is here. D square plus 16 into y is equal to cos square 2x plus e raised to 2x. Here, auxiliary equation is, this is the reduced form of LD. Auxiliary equation is d square plus 16 is equal to 0. D square is equal to minus 16. Square is a negative number. So there we introduce I square. And so the factors are plus minus 4i. So the complementary function, that roots are complex roots, plus 4i minus 4i. Here real part of the complex number is 0. So the complementary function is c1 cos 4x plus c2 sin 4x. You go through the rules of complementary function, then you have an idea how to write the complementary function for complex roots. So from that rule, we have written here the complementary function. Now PI, how to find the PI? Phi of d is d square plus 16. So 1 upon d square plus 16 into function is cos square 2x plus e raised to 2x. Separate both the terms. Separate both the terms. So 1 upon d square plus 16 into cos square 2x. We have written here the formula for cos square 2x. The formula is here 1 plus cos 4x by 2. Double angle formula. And e raised to 2x as it is. Separate these two terms. Now again there are two terms, 1 plus cos 4x and 1 by 2 is common for both. So separate both the terms, 1 upon 2 into 1 upon d square plus 16 plus 1 by 2 into 1 upon d square plus 16 into cos 4x plus 1 upon, we'll solve this term here. When there is exponential function, we replace d by the coefficient. The coefficient is here 2, so replace d by 2. 2 square 4 plus 16 into e raised to 2x. And so this 1 by 2 as it is. Here it is a constant term. When there is a constant term 1, constant term is 1 here. Then, sorry, this 1 by 2 is here. Then in that case, we replace d by 0. If we replace this d by 0, it is 1 upon 16. 16 to the 32. So 1 upon 32 plus this 1 by 2 as it is. Now how to solve for cos function? Replace d square by minus a square. So what is the value of a is 4. The square of 4 is 16. So replace d square by minus 16 here. Here replace d square by minus 16. Sorry. replace here d square by minus 16. It is not minus 4, it is minus 16. Minus 16 is here. Draw here minus 16. Here you can write here replace d square by minus 16 minus 16. Okay. Replace d square by minus 16. And if we replace d square by minus 16 plus 16, 0. So it is the case of failure. So so it is the case of failure. So multiply in numerator by x, take the derivative of denominator. Derivative of d square is 2d, cos 4x plus 1 by the 16 plus 4, 20 e raised to 2x. And after simplification, we have this result, pi. 1 by d integration of cos 4x is sin 4x upon 4. And after simplification, we have this pi. And so the general solution is y is equal to CF plus pi. This is your answer. So here the second case is over. First and second case are over. Thank you very much.